Now it is about combining the resistors.
Perfect.
Okay. You know what a resistance is. You know how to calculate the value of resistance with the help of voltage and current. And also you know how to find the value of resistance with the help of what do we call as the length, the area, and the resistivity.
Yeah.
Okay. Now we will see how they will get combined, how resistance can be combined. So for that, let me show you a whiteboard. Can you see here?
Yes.
Now, usually the resistance, the resistance is, the symbol of the resistance is this. Okay. This is a very simple symbol of a resistance, which is like a rectangular box.
Okay.
Okay. It is used, same is used for IGCSE and same is used for IBDP also. Cambridge
Okay.
and IB both uses the same type of representation for the resistance. Okay. So
Yeah.
there are two ways how I can combine resistors. Okay. Now I have, now what I'm going to do, I have a group of resistors connected with each other. And there are two ways how it can happen. They can be connected in two ways, right? So those two ways is, the first one is called the series combination. First one is called as the series combination. And the next one is called as the parallel combination. Now let me tell you, a lot of problems will be there on basis of this.
Okay.
A lot of problems will be there, which we'll be seeing today. But first, let's understand what are these combinations. And there will be parallel combination. There are two types of combination. A resistance can be connected in series combination and parallel combination. Now, let's look into a resistor first. If you look here, I'm making a resistor in a bigger way so that you understand. This is the resistor. See, resistor is bidirectional. That means it does not have any positive or negative. If you take a
Okay.
cell, it has a positive, negative, right?
Yeah.
And that positive, negative decides the direction of the current which it can go. But for a resistor, it does not have any direction. Current can flow like this, or the current can flow like this in this direction. It doesn't matter. It will provide resistance to current flowing in any direction. So that's why it is bidirectional component. Okay,
Mm.
which does not have a direction. You see,
Okay.
ammeter, voltmeter, they all have directions. If you don't put them correctly, they will show you an opposite reading.
Okay.
Okay. So ammeter and voltmeter are directional. Even a cell is directional, whereas a resistor is non-directional. Current can flow through any point. Now, let me create a series combination. Okay. Now let me imagine that the current is coming in this direction and going in this direction, right? This is the
Yeah.
direction of current. Let me assume that this is the direction of current. So I will say that this is A and this point is A, this point is B.
Okay.
Now, when I connect, so I will call this as the starting, ending. No, actually in real, they don't give you names like this. I'm just telling you these names so that you understand what I'm trying to say. Okay.
Yeah.
Let me call this a starting, ending. A is starting, B is ending.
Yeah.
Now I'm connecting another resistor like this. Similar, not similar, another resistor like this. And in this resistor also, you see the current is flowing like this. So this is the starting of this resistor, and this is the ending of this resistor.
Yeah.
Same can happen, and I can have a series of resistors connected like this, like starting, ending, starting, ending.
Yeah.
So when the starting of one resistor is connected to the ending of another resistor, it is like a connecting a pipe through which a water can flow. So I
Yeah.
have a pipe like this. water is flowing here. Now, if the continuation has to happen, I have to connect another pipe. So that means starting of this pipe has to be connected to the ending of this pipe,
Yeah.
isn't it? That is how the water can flow for a longer distance.
Yes.
This particular connection of this particular combination of resistors is called series combination.
Okay.
Okay, it's called series combination, and you can have 100, 1,000 resistance, how much ever you want. You can keep it in the combination. But in real, we don't keep 1,000 and all, but like we can have 10, 20 in series. So this kind of combination of resistors is called as the series combination. Okay.
Yeah.
Now you see what are the things that are happening in series combination. Okay.
Okay.
Okay. Before that, first let us see. Before you go to the other aspects of series combination, we will see what is parallel. Okay.
Okay.
So this is series. When you connect the resistors in this way, we call it as series combination. Okay. Now I'm going to do another connection, another type of connection. For that, I will clear my torrent. Now this is my resistor. And in this resistor, the current is flowing like this, as usual. This is my A, the starting point, and this might be the ending point. B, A, and B. Now, what I'm doing, I'm bringing another resistor. Okay.
Yeah. Okay.
And I'm bringing it here. And for that resistor, I'm connecting it like this.
Hmm.
Now you see here the current, of course, the current again is flowing in this way only. And you see this is the starting point of the second resistor. And this is the ending point of the second resistor. Now
Yeah.
here, starting point is connected to a starting point, ending point is connected to ending point. Yes or no?
Yeah, that's right.
In the previous one, starting point was connected to ending point, isn't it? A starting point
Yeah.
was connected
Yeah.
to ending point. Here, a starting point is connected to the starting point itself. Starting
Hmm.
point is connected to starting point itself. Now, the series, how to grow this series? You can add more and more resistors in the same way. So you look here, the starting point of this resistor is also connected to the starting point of this and this together. So it's like all the starting points are connected together.
Yeah.
I can have n number of resistors connected with all starting points together, all ending points together. This type of combination is called parallel combination. Understood. This type of combination is called as the parallel combination. Now, actually, it is not difficult to understand. Visually, if you see, you will quickly understand that what is parallel, what is series. It doesn't take much time, because once you keep doing more problem, once you keep seeing many types of circuit, you can actually visually see it and understand it in 2 minutes. Not 2 minutes. Within 2 seconds, you'll understand,
Hmm.
yeah, this is parallel, this is series.
Yeah.
Okay. Anyways, that comes with practice only. Okay. That comes with practicing problems and all those. Fine. So till here, did you understand?
Yeah. I get it so far.
Okay. Now I will quickly take you to the textbook and show you a few things very important. So let me screen share to you. Can you see this series? What type of okay, this is combination, so I cannot ask you.
Oh, okay.
So there are actually combined also, like
Yeah.
series and parallel together also will be there, but I will tell you what are they. Like
Okay.
complex circuits. Complex circuits are those who have series and parallel together. I will tell you what is complex circuit also. What is this combination called?
This one's a series.
Very good. What is this combination called?
That one's a parallel.
Very good. series combination is there, parallel combination is there. Now, let me show you how complex looks like. Okay, so this is where we'll practice a little bit more. Let's see how a parallel combination looks like. So if you
Okay.
see here, I'm going to show you one circuit. So I'm actually making a circuit. You will understand what I am talking about. If you can see, there are four resistors connected in a group.
Yeah.
It's a complex circuit. Can you explain this complex circuit?
Um.
I'll name them R1, R2, R3, R4.
Yeah. R1 and R2 and
Hmm,
R3 and R4 are both in their own parallel.
very good. So you can say in this way that R1, R2 are in parallel, R3,
Yeah.
R4 are in parallel. Okay, next.
They are both also in series of each other.
Very good. The combination of R1 and R2 are in series with the combination of R3 and R4. Yes?
Yes.
Okay, now I'll make one more circuit. So yeah, that's all. These are called complex circuits. Very easy to understand. You understood it very quickly. Okay, now next one is like this. Okay, now I'm making a diagram here. You can understand. And yes. Okay, now R1, R2, you have R3, and you have R4. Now, can you explain me the circuit?
R1, R3, and
Hmm.
R2, R4 are in series.
No, okay.
Oh yeah, R1, R3 are in series of each other, and R2 and R4 are in series of each
Yeah, you have to explain in that way because when you start explaining in that way, it will start helping you to do problems.
other.
You
Okay.
cannot say that R1, R3, R2, R4 are in series. No, they are not in
Okay.
series, first of all. You have to
Yeah.
say R1 and R3 are in series, R2 and R4 are in series first.
Yeah.
Then the combination of R1, R3 and the combination of R2, R4 are in parallel. That
Yes.
is how your statement should be because the same
Okay.
statement you will use for doing problems.
Perfect.
Yeah, of course, you will understand when we do problems that, but now you are understanding these complex circuits basically.
Yeah.
Okay. Now, the next thing that I want to tell you about is this a very interesting thing and a very logical thing that you should remember.
Okay.
First, let me tell about the series, what happens. Let me take a circuit, not circuit, a combination which has three resistors in series like this. Okay, I'm not going to show you the derivation part of it, but few important things that are required. Now, this is R1, this is R2, this is R3. Okay, now let's imagine that I'm connecting it to a hypothetical battery. I'm connected to a battery, and this battery is providing a voltage for the whole circuit. And I would say that this is somewhere around 20 volts.
Okay.
Okay. Now, because of these resistors, there is a current I going to flow through the resistors.
Yes.
So can I say that all the resistors are flowing the same current?
Yes.
So these resistors are like city which have a same river connected. So
Okay.
whichever water flows through R1, same water flows through R city R2, same water flows through city R3 also. Yes or no?
Yes.
So I can say that current I flows in all the resistors who are in series. So my statement is the resistors which are in series flow the same current. Agree?
Agreed.
The resistors who are in series flow the same current. So R1, R2, R3 are in series with each other. So they will be flowing same current through them.
Yeah.
Yeah. All right. Now that is about the current. I would write that current is same.
Okay.
One second. I will say that current is same. You look here. Current is same for all. Okay.
Right.
Now let's talk about voltage. When I talk about voltage here, voltage is going to be distributed. I won't say be divided, distributed according to the resistance. Voltage is going to be distributed according to the resistance. And
Right.
let's imagine if the voltage of each, okay, so that means when the voltage is going to distributed among all the components, R1 will have a voltage V1, R2 will have a voltage V2, and R3 is going to have voltage V3. But you know what's the interesting part? What connects them? It is V1 plus V2 plus V3 is going to be 20. So the
Oh,
component which is providing the voltage, that is the battery's voltage, is going to be divided among R1, R2, and R3. When you add them, you are going to get the total voltage of the battery.
okay.
Okay, so this is what happens in series connection. Voltage is distributed. I won't say divided. Voltage is
Distribute.
distributed. And it gets distributed according to the resistance. How? Here, I will use my Ohm's law. How will I find V1? V1 is equal to I into R1. I is common, right, for me?
Yeah.
R1. V2 is equal to I into R2.
R2.
So actually, I'm using the concept of Ohm's law only here.
Yeah.
I into R2. Now V3 is equal to I into R3.
Correct.
I into R3. So this is the case of a series connection. Till here, are you following?
Yeah.
One second. Okay, are you following till here?
Yeah.
Okay. Now we say that the total resistance in series is nothing but R1 plus R2 plus R3. R1 plus R2 plus R3. Remember, I'm talking about only these three. Okay. If there are more n number of resistance added, it can be going till Rn also. Understood? It can go till Rn
Yeah.
also. Clear?
Yeah. Yeah. Correct.
Okay, fine. All right. Now let us move forward. And I will just show you in the textbook. Okay, you have that formula in the textbook, so I need not show you there. Okay, next I will take you to the parallel part. Okay, so you are having writing the notes, all right, with you.
Yeah. Writing notes.
Okay, because I am deleting it now, that's why. Anyway, see, I'm telling you again, you will understand everything that I'm telling completely only when you do problems. These are
Okay.
just a theoretical part which you are seeing. Okay. The fulfillment, the complete things will be complete only when you do problems, which we'll be doing in some time. Once we complete the parallel part, then we have to get into problems. Because if you don't do it, you will forget, not forget, you will just miss out that thing, which I discussed. So it's
Hmm.
like, you should catch it when it's hot. That's the thing which you have to do now.
Yeah.
Now I have three resistors that are connected in parallel. I have three resistors that are getting connected in parallel like this. Three resistors connected in parallel. You have R1, you have R2, and here you have R3. Okay. Now let me consider that I'm connecting a battery, external battery as usual, to this combination of parallel circuits. Now let me imagine that this is 20-volt battery. So now this 20 volt is being provided to all the resistors in parallel, that is R1, R2, and R3. Now you know what is the interesting part? In this, all the resistors are going to have same voltage 20. Understood? In the previous case, your current was same. In this case, your voltage is same.
Is that because it like when it hits it, it cuts into its own paths to meet each resistor? So the voltage will be 20 for all
No,
of them?
no, no. Voltage depends on where they are joining. See, all of them have same starting and ending point.
Yeah,
So what is the voltage being provided to all the starting and ending point? It's 20 only.
20. Yeah.
So all of them are having same voltage 20.
Okay.
But current is different. Let me
Oh,
consider that current I is flowing here. But here what is going to happen? Current is going to be divided into three branches. Here
right.
I1 will go. Current is like a flowing water, I told you, right? It has to go. It has to, get divided when it is in parallel.
Yes.
And this is going to be I3. And the total current is the total current in the circuit is equal to I1, I1 plus I2 plus I3. The total current in the circuit is I1 plus I2 plus I3, right? So what I can say is that current is different for them. Voltage is same, but current is different. Is that clear to you? Voltage is same, but current is different.
Got it.
Okay. Now, since they are connected in parallel, their combination also has a formula. Combination of resistors in parallel. And that formula is the total resistance total resistance R is equal to 1 by R plus 1 by R1, 1 by R1 plus 1 by R2, then plus 1 by R3. So this is for the system of three resistors together. If I have n number of resistors, it's going to be 1 by Rn. Is that clear to you?
Yeah.
Now these formulas and these tools are clear for you.
Yes.
Now
But
it's
I have
time.
a question.
Yeah, tell me.
If resistance has been written in the form 1 over R,
Hmm.
um, aren't we finding the inverse of the actual resistance?
No, here you need not go for the fraction. Just
Okay.
do the LCM and get the answer. Like what
Okay.
is 1 by 20? See, I will just give you an example. Let's imagine that this is 30 ohms, this is 20 ohms, and this is
Got
10
it.
ohms.
Got it.
Let's give a random number for this. So my 1 by R is equal to, so they're asking me to find the total resistance of this parallel. So 1 by R is equal to 1 by 30 plus 1 by 20, isn't it? Same thing what
Yeah.
I'm doing. 1 by 20 plus 1 by 10. So taking the LCM, I know that the LCM is going to be 30, not 30, sorry, 60, isn't it?
Yeah. Yeah.
LCM is going to be 60. This is going to be 2. This is going to be 3. and this is going to be 6. Yes?
Yeah.
So 2 plus 3 plus 6, 12. 12 by 60. So it's going to be 12 by 60. So 1
No,
by
no, no.
R.
It's 11 by 60.
Oh, 11 by 60. So 1 by R is going to be equal to 11 by 60. 11 by 60.
60. Yeah.
1 by R is 11 by 60. So what is your R?
It will be the inverse of that.
60 by that.
Yeah.
So your R value for this combination is 60
60 by
by
11.
11. So this is how you find out.